All right, so this is our introduction to polynomial functions. This is the pre-graphing portion to make sure that we know what a polynomial function looks like and how to find a couple of things before we start graphing. So it starts with a warm-up where you have to graph a quadratic, which is a polynomial, hence the warm-up. So you can go ahead and pause the video and try that out yourself. All right, let's see how you did. Here's what it looks like. So this is the polynomial function or the quadratic function f of x equals 1/2 times x plus 3 quantity squared minus 2. The parent function is y equals or f of x equals x squared, which I have graphed there in red. It has points 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, so on and so forth, and their reflections over the y-axis. It says write a rule for the transform graph. This is moved right 3, left 3, so that's x minus 3. And then there is a vertical compression of 1/2, and it is moved down 2, so 1/2 y minus 2, and then my blue graph there is what it looks like. All right, so let's get started on today's notes. So we're talking about polynomial function. It says a polynomial function is of the form, and then it gives this crazy looking function right here. F of x equals a sub n times x to the nth plus a sub n minus 1, so on and so forth, right? It's crazy. But if you look at the note there, it's just saying a sub n, so whatever, I'm going to highlight what it's saying. This, those are just coefficients, right? So just like the coefficients here are 1, 4, 4, those are just those numbers there. They're real numbers, they can't be imaginary, okay? And n is a non-negative integer. So if we go back to what n is, if you look back, it's that sub there, so also n is right here, it can't be negative. So I'm stuttering over my words here, that n right there, that exponent cannot be negative, okay? So all of your exponents have to be positive and your coefficients have to be real numbers after I just stuttered all over that, okay? So what we are going to do in this little section right here, because in these notes, all that I'm really asking you for are just a few things. Well, when we go to graph, we'll do more, but for now, this is what I want you to know. So this is analyzing f of x in its graph, and then on the right-hand side, we'll do it for a specific polynomial, which is right here. So we'll actually do it specifically for that polynomial. So first off, the degree. Okay? The degree is the highest exponent when the polynomial is written in standard form. So if you look right here on the polynomial above, this is written in standard form. The highest exponent would be the one that's first when it's written in standard form, so that's just n. But once again, it's the highest exponent when written in standard form. Highest exponent on x. So in this one right here, this is written in standard form. The degree of this, the highest exponent is 3, okay? A polynomial function has at most blank real zeros. So if the highest exponent is the degree, that's also the most amount of real zeros that it'll have. So it's the same amount, which is n. And notice it says at most because it can have less than that. Can't have more, but it can have less than that. So on this one right here, this at most is going to have 3 real zeros or 3 real solutions. It could have 2 because 1 can be repeated, or it can have 1 the other 2 can be imaginary, right? But at most, it'll have 3 real zeros. The number of turning points at most. So if it has n number of zeros, it has at most 1 less than that turning points. So that would be n minus 1. So in this case, the number of turning points in this at most one's in because it could have less than that. 3 minus 1, which is 2 turning points. I stumbled a lot over my words there, but I just have trouble thinking of how to put it in my own words when I can just be reading what it says. All right, so in these examples, the directions look the same on all of them. So I'm going to give you a function, and we have to state whether or not it's a polynomial. If it's not a polynomial function, then tell why it's not. If it is, then you're going to answer the question. So if it's not a polynomial function, we don't have to answer B, C, D, E, F, okay? All right, so first off, is this a polynomial function? So looking at it, remember, in order for it to be a polynomial function, it has to be in this form right here, right, expanded form, which this is. And then it has to have real coefficients, which I don't see any I or square root of negative numbers anywhere, so that's good. And then the exponents have to be non-negative. And if you look, they are. So yes, this is a polynomial function. Okay? And the reason why it is it's in the form f of x equals, those reasons I said out loud. It's in the form f of x equals, it's expanded. It has real coefficients, and it has non-negative exponents. I always want to say positive, but 0 is also one that works. Okay, so it says, if yes, answer the following questions and write it in standard form. So we did say yes, so we're going to write it in standard form because it's not written in standard form. We have f of x equals, our highest exponent is a cube, so we're going to write that first, negative 4x cubed. Then our square, which is plus 5x squared. Then our linear term, which is plus 3x, and our constant, which is minus 4. What's the degree? We could have just looked at it and said, oh yeah, it's 3 right here, but now that it's written in standard form, it's going to be the first exponent, which is 3. The leading term is the coefficient plus, so it's not just the coefficient, the leading term is the one that is written first once it is in standard form. So that would be negative 4x cubed. The leading coefficient is the number on that, but the leading term is the entire term. What's the constant term? I called it a constant term when I was writing it. That's negative 4, and that's this one right here. So I want to point that out, that it's not the leading coefficient. It's that term that has x to the 0 power on it, which we don't write x to the 0. What's the maximum number of zeros? If the degree is 3, then at most it's going to have 3 real zeros. What's the maximum amount of turning points? If there's 3 zeros, then it'll turn at most 2 times, 1 less than that. Okay, let's move on to the next one. First off, is it a polynomial function? So if you look at it, it's not in standard form, but it is a polynomial function. I can multiply this out, and it will have lead coefficients that are non-imaginary, and it will also have exponents that are not negative, right? And I could write that down, but I'm not going to. Also, if you look at it, it's a quadratic. Like quadratics are polynomials. Write it in standard form, so we are going to have to multiply it out. G of x equals, and then multiply that out. The first 2 terms being multiplied are 2x squared. Outer is 3x and inner is negative 8x, so that's negative 5x. And then negative 4 times 3 is minus 12. So notice it is a quadratic, which it's in standard form right there. It is a polynomial. The degree, the highest exponent is 2. The leading term is 2x squared. The leading coefficient is 2. The constant term is negative 12. The maximum number of real zeros that you can have is the same as the degree, and the number of turning points is at most 1 less than that. One thing that I do want to point out is that we could not get the degree when it's written in factored form or intercept form, okay? We do have to have it in standard form so that we can see the degree. Or you can say, all right, I'm going to multiply my first terms to see what my first term is. X times 2x is 2x squared. Now you have your first term, and you can see your degree and your leading coefficient. All right, next one right here, tell whether the following function is a polynomial or not. So if you look at this, this is not a polynomial. This is a rational function. And if we can't have a denominator with an x in it. That's just not allowed, because if you think about it, this, to bring it to the top, this is to the first power, I would have to make a negative exponent in order to write it out, and that's just not going to fly, right? So I could rewrite this as x squared plus 4, bring it to the top, x minus 1 to the x minus 3 to the negative first power, and then multiply that out. But that's just hideous. Negative exponents, I can just look at it right here. Hideous, right? Negative exponents can't happen, okay? All right, so whenever you see something looking like this is not a polynomial function. This is a rational function. This is a rational function, which is our next chapter. Did I circle yes on the other one? Yes, I did. Okay. Do I have to write it in standard form? No, because it's not a polynomial. I can discuss the degree of the numerator and the degree of the denominator. The degree of the numerator is 2, the degree of the denominator is 1, but since it's not a polynomial, I don't have to answer any of those questions. All right, example 4, same directions. Is this a polynomial? It's in factored form, but if I multiply it out, I can get it in that general standard form of a polynomial, so yes, it is. The coefficients on my terms are all real, and my exponents will all be positive. Oh, write it in standard form. So we are going to multiply this out, okay? I'm going to multiply it out like right here and then just write the answer down there. So I have h of x equals, I'll multiply these two to make it x squared plus 2x, right? Then I will multiply x minus 1 times x minus 1, and that gives me x squared minus 2x plus 1. This is still not in standard form, right? So we want to get it in standard form by multiplying it out. So just be careful. I'm going to do x squared times x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times 1 is x squared. And now I'm going to distribute this 2x. 2x times x squared is 2x cubed. 2x times negative 2x is negative 4x squared. And 2x times 1 is 2x. Now I'm going to combine like terms so that it's in standard form. So I have h of x equals x to the 4th. I'm going to combine my cubic terms. Negative 2x cubed and positive 2x cubed cancel out. I have an x squared and a negative 4x squared, so if I combine my quadratic terms, that's minus 3x squared. And then my linear term is plus 2x. Notice there is no constant term this time. So the degree on this, the highest exponent is 4. What's the leading term? X to the 4th. What's the constant term? There, 0, right? And I wouldn't put there is, it's just not written down, it's 0. Maximum amount of real zeros is the same as degree, 4, and then turning points is 1 minus that, so 3. Okay? So really quickly, if it didn't ask me for standard form, I can still get this and therefore still can answer this. So if you notice here, it was x to the 4th, and you can get that just by multiplying your first terms. So if you look at what you would get for your first terms here, you have, let me use my highlighter, you have x times x to the, well, this is x to the first power. This is a first power here, so that's another x to the first power. And then this is an x squared. So if I did x times x squared, I do get that x to the 4th power. So I could answer those questions without multiplying it out completely if it didn't ask for me in standard form. All right, that's it for today. We'll do some more practice with graphing